Welcome to this video on the topic of linear relationships. In this video, we'll be exploring the mathematical concept known as perpendicular. Now, the perpendicular line relationship occurs when two lines intersect at a 90-degree angle. Observing an example of this is consider two lines, and the way in which they intersect, we get a right angle in between, or a 90-degree angle in between. So what we're looking at here is the equivalent in coordinate geometry, where we have two lines that intersect, and the intersection is a 90-degree angle. Now, the way in which we check for this is we have a rule, much like we do for the parallel line check. What we can say is that two lines are perpendicular if the multiplication of gradients m1 and m2 are equal to -1. Now, applying this rule over an example A over here, we have check whether the following lines are perpendicular. And we have line y1, which is equal to 2x plus 2. Then we have line y2, which is equal to -1/2 x minus 2. The way in which we're going to check whether these two lines are parallel is we'll set ourselves up and go A, checking. Then we need to identify our two gradients, so m1 and m2. For m1, it's going to come from line y1, and it's simply the 2 in front of the x here. So m1 is simply equal to 2. For gradient m2, we're looking at line y2, and it's simply going to be -1/2, because again, that's the coefficient in front of x. So -1/2. Performing the check, all we need to do is we write out our check formula, so m1 multiplied by m2, sub in the values, 2 multiplied by -1/2, and thus we find that the result of these two is equal to -1. Consequently, what we are able to say is that because the result is -1, therefore lines y1 and y2 are perpendicular. So what we've been able to see in this example here is how we might go about setting out our workings out for checking whether two lines are perpendicular. If we wanted to finish it off, we could draw a perpendicular line indication here, just showing that the lines are parallel. But we don't have to do that because we've done it down there. Alright, now in addition to being able to check whether two lines are perpendicular or not, we're also able to calculate the gradient of a line that's perpendicular to another line. Now, the way in which we do this is we have a formula that we use. We rearrange what we had up here and change some of the variable names, and we're going to write it as n is equal to -1/m. Now, the naming convention of the variables here, the variable n over here, this represents what we call the normal. The normal being the gradient of a line that runs perpendicular to another line. And furthermore, the value of m, that's simply the gradient of the line that we're trying to deduce a perpendicular line to. So this is the formula we use when we're trying to calculate the normal, or the perpendicular line to a line that we already have. Now, applying this formula here, what we've got is, we've got an example down here, and it says, calculate the gradient to the normal of a line y1. So we've got line y1 down here, and it's y1 equals -2x plus 1.5. What we want to do is we want to calculate the gradient inside this equation here, y2. Now, the way in which we're going to do this is we're going to use this formula here. Calculate the value of n as seen here. So the way in which I'm going to do this is m is equal to -2, as seen here, and then I'm going to say n is equal to n, or I can simply leave that step out. Now the next part I'm going to write out is n is equal to -1/m. Calculating this, subbing in the value for m, we're going to get -1/-2, and because we've got a double negative, they're going to cancel out. So we're going to get a gradient for the normal to be simply 1/2, or we can write it as n is equal to 0.5. So what we're going to find is that the value of n, as seen over here, and seen here, is just going to be equal to 0.5. And thus, we're able to calculate the gradient of a normal to a line such as seen in y1 over here. Now, in summary, what we set out to do in this video was we wanted to have a look at the mathematical relationship we define as perpendicular lines. For the first part, we had a look at how we can check whether two lines are perpendicular or not. And then in the second part, we had a look at how we can calculate the gradient of a line that runs perpendicular to another line.